Okay, good morning. Welcome to
And math number 559.
FamilyMath559. So, a couple days ago, we did a project on x squared plus y squared and x plus y squared. And I gave the, actually I ran into a high school math teacher from Wisconsin when I was at MIT one day. And I gave those to her because I happen to have them with me. Because I don't have those shapes anymore. Do you remember what the shape x squared plus y squared looked like? We had made it on a square where x goes from -2 to 2 and y goes from -2 to 2.
It sort of looked like a three-dimensional parabola.
Why don't you draw it to the best as you can?
I mean, like, one part of it sort of looked like this, like if you look at it straight on.
Okay.
Then there's this empty space here because as the circles that made it up got bigger and bigger, it went outside of our box that we were putting them in.
Okay, good. Yeah, and what about x plus y squared? What did that look like?
This looked sort of like V shape, where from the side it actually got smaller like this, and again because it would actually look more like it's a V shape made out of lines, so it would be infinitely long, but the space here just got outside of the box.
Okay. Yeah, very good. The only thing I would correct is that it's not actually a V. It's a parabola also. It does. You're right. It did sort of look like a V, but it wasn't. It's not a sharp point at the corner.
It's more like
on that one. It's curved.
It's like
yeah, and that just comes like if you freeze, say when y equals 0 or something, you get x squared.
Yeah.
So it comes from the parabola. So today we're going to do a similar project, kind of extending off of what we were planning to do before. We're going to look at these two equations: square root of x squared plus y squared, and what happens if I bring the square root through sort of naively. Square root of x squared is square root of y squared. In fact, the first lesson in this is what is the square root of x squared?
Well, that's plus or minus x.
Okay. And under what circumstances is it plus x, and what circumstances is it minus x?
Well, I mean, for your x, you can so for each of these x, you could square it and get the same result, like 2 and minus 2 both square to become 4.
Okay. And what is the square root of 4?
Square root of 4 is it's the absolute value of 2.
Okay.
So
the square root of 4 is
2 or minus 2.
No. The square root of 4 is not 2 or minus 2.
It's the absolute value of 2.
Which, if we were going to say that as a number, is what?
2.
2. So the square root of 4 is
2.
2. The square root of x squared is
X.
No. That's why this is a little tricky. So the square root of 4 is 2, which means the square root of 2 squared is
2.
2. So that means the square root also of minus 2 squared is
2.
2. So does that tell you what the square root of x squared is?
It should be x. But absolute value of x.
Aha. Square root of x squared is absolute value of x. Because you're right, it's either x or minus x. So the square root of x squared is x when x has what property?
When x is positive.
Yeah, when x is positive. Or we could also include 0 if we wanted to. But when is the square root of x squared minus x?
Well, when x is negative.
Negative. So when we naively bring the square root through to each term, we get absolute value of x plus absolute value of y, if we do the square roots correctly. So we're going to compare this shape, absolute value of x plus y, to the square root of x squared plus y squared. And we're going to see, are they the same or are they different? All right. So that's an important lesson already with the absolute values. So let's go on and see if we can identify what the shapes might look like.